Welcome, this is the solution for the 2.2 ready, set, go. The first part, we have the ready. It says state which situation has the greatest rate of change. Alright, the first one, you have this scenario. So what I decided to do was I put the first one into a ratio because rate of change is referred to a ratio. Okay? 6 inches when stretched by 3 pounds weight, 6 inches over 3 pounds. I simplify that to 2 inches and 1 pound, right? Notice that the units are the same for the other one, 3 feet and 1 pound weight, right? The fact that it's all under 1 pound, I can now compare it. 2 inch or 3 feet. 3 feet is much bigger. Okay. 6 inches, yep, by 1 pound weight. Good. Next, okay, we have this. Again, 2 inches per day was my first ratio. The second one is 8 inch in 1 week. Right? Notice how here it was 1 day, but the other one was in 1 week, so I had to convert it. So what I did is there are 7 days in 1 week, so I multiply it by 7. So 2 inch sunflower multiplied by 7 gets you 14 inch for the sunflower, and that is in 1 week. Now I can compare it. 18 inch or 14 inches in 1 week. 18 inches in 1 week is much greater. Next one. Okay. We have 25 gallons in 3 minutes, and the other one was 40 gallons in 5 minutes. Okay. Oops, sorry about that. Right. Here, 25 gallons of gas in 3 minutes, and the other one was 40 gallons of water in 5 minutes. Right? You're looking for something called the greatest common factor of 3 and 5, which is 15. So I had to multiply this by 5. That's how I got 125 gallons of gas over 15 minutes. The other one, multiplied by 3, 40 times 3 is 120. 120 gallons of water over 15 minutes. Once it's over 15 minutes here, I can then compare it. I saw that 125 gallons of gas, it's much greater. Number 4, riding a bike 10 miles in 1 hour or 3 miles in 24 minutes. Okay, again, I put it over 1 hour. 10 miles over 1 hour, and the other one was 4 miles jogged over 24 minutes. The greatest common factor was 2 hours, so I had to multiply this by 2. It becomes 20 miles for the bike ride in 2 hours, and here I had to multiply this by 5. Okay, it gets me 20 miles and at 120 minutes or 2 hours. Notice that it's the same value, so I say they're both equal here. Okay. Set. Identify whether the following items best fit a discrete or continuous model, then determine if it's linear or exponential. The first one. The freeway construction crew pours 30 feet of concrete per day. The domain is day, and the range is concrete. The day is continuous because you can have 1.5 days. Right? 1.5 days, cutting the day in a 0.5, it's still a day. The essence doesn't change. Right? And time. Okay? It's linear because every day there's an increase by a constant rate of 300 feet of concrete. Number 6. For every hour that passed, the amount of area affected by the bacteria doubles. The domain here is hours, and the range is the bacteria amount. The hours is continuous because you can have 1.5 hours. It's still hours. The essence of the hours doesn't change. It's exponential because every hour there is an increase by a percentage amount. That percentage amount, that double, indicates that it is exponential. 7. To meet the demands placed on them, the bricklayers have started laying 5% more bricks per day. The domain is days here, and the range is your brick laid. Okay. The day is continuous because you could have 1.5 days. And it's exponential because every hour, every day, there is an increase of a percentage amount of 5%. 8. The average person takes 10,000 steps in a day. The domain here is days. The range is your steps. The day is continuous because you could have 1.5 days. And it's linear because every day there is an increase by a constant amount of 10,000 steps. 9. The city of Buenos Aires has added 8% to its population every single year. The domain here is years. The range is your population. Year is continuous because you could have 1.5 days. It's exponential because every single year there is an increase of a percentage amount of 8%. 10. At the headwater of the Mississippi River, the water flows at a surface rate of 1.2 miles per hour. The domain here is hours and the range is water flow distance. Okay. Hours is continuous because you could have 1.5 hours and it is still hours. Linear because every single hour there is a constant amount of water flowing, which is 1.2 miles. Alright. Next, you have this equation. The domain of the sequence consists of all natural numbers, or 1, 2, and 3, and 4. The range of the sequence consists of all the terms in the sequence. It's linear because there is a constant amount increasing of 3 for each term in the sequence. Notice that this is the recursive for the arithmetic sequence, which is linear. I should have 11b right here. Yep, 11b. There should be an image. Okay. The domain of a sequence consists of all natural numbers, counting 1, 2, 3, and 4. Oh, it's right here. Here's the graph. Right. The range of the sequence consists of all the terms in the sequence, so I think it goes from 60 all the way down to 0. The exponential, because there is no constant slope, it's exponential because there's a non-constant slope. Do you see how it's dramatically decreasing down? 11c. Here we have the domain of the sequence consists of all natural numbers, counting 1, 2, 3, and 4. The range of a sequence consists of the terms in the sequence. It's exponential because this is the explicit for the exponential form. The common ratio here is 2. The starting term is 7. Okay. We should have our go now. Let's see. Yep, here's our go. Alright. Alright, we're just solving for the equation. 1x plus 16 equals to 36 is writing the equation. Subtract 16 to both sides. I get 1x. Okay, the 0 plus equals to 12. I highlighted it wrong. Give me a second. Okay. Alright. I make that 0 element there for simplification. Then it is x equals to 20. Because the 0 disappears, just becomes x equals to 20. Next one, 1x minus 13 equals to 10. Add 13 to both sides. You get, again, that should be black. The green here. The green here indicates the 0 element. Right, the identity element. Simplify. That becomes 0. 10 plus 13 is 23. The answer is x equals to 23. Add 8 to write your equation. 1x minus 8 equals to negative 3. Add 8 to both sides. Once you simplify, the identity element here is 0. It's x equals to 5. Negative 3 plus 8 is 5. 14. 8x equals to 56. Write the equation. Divide 8 to both sides because you're trying to get the variable alone. You get 1x equals to 7. Notice how it's a 1 because 8 over 8 is 1. Simplify into x equals to 7. 15. Negative 11x equals to 88 is the equation. Divide 11 to both sides. The left side, negative 11 divided by negative 11 is 1. 88 divided by negative 11 is negative 8. Your answer is x equals to 8. 16. 425x equals to 850. You write the equation. Divide 425 to both sides. Okay, simplify. 425 divided by 425 is just 1. 850 divided by 425 is 2. So it's x equals to 2. 17. 1/6 x equals to 10. Right? This is a fraction, right? 1/6. So you're multiplying 6 to both sides. 6 over 6 is 1. 10 times 6 is 60. So the answer is just x equals to 60. 18. Negative 4 over 7x equals to negative 1. multiply by its inverse. So in this case, it is negative 7 over 4, right? You just flip it, okay? Right? You get a 1 here. That's the reason why you flip it, so you can make that 1, right? On the right hand side, it just becomes negative 7 over 4. There you go. 19. 4x equals to negative 9. Multiply by the reciprocal, so flip that. It's 4 over 3. 4 over 3. Multiply, you get 1x equals to negative 12. Simplify, x equals to negative 12. And there you go. Those are all the solutions.